Hello students, today we are here to discuss the syllabus of class 9th, first chapter, the remaining portion of first chapter. So we will start from the topic, what is computer? We have lots of definition in our mind that computer is an electronic machine, computer is an electronic device, and blah blah blah. We have lots of definitions. So one thing I would like to say before reading the definitions, before explaining the definitions, whatever we read in science, whatever we read in our daily lives, we have one reference point to compare that subject. And suppose if you are studying physics, you have to compare with your daily life. Everywhere we can see the application of physics. If you wish to compare mathematics, mathematics in our daily routine also. If you wish to correlate chemistry, chemistry is in our home, in our kitchen. So we can compare, we have a reference point for all the subjects. We have to find that reference point. But do you know what is the reference point for computer? Means to whom to compare with computers? Yes, yourself, ourselves. Computers are our competitors. Computers are our competitors. Means computers are the competitor of humans. So you have everywhere. If you will compare computer with yourself, you will get clear knowledge of what the computer wants to say. Means what the definition wants to say, you may get a clear definition. We will see in our next slides. So the simplest definition, the basic definition of the computers: one who computes is known as computer. One who computes is known as the computer. Computer is a combination of hardware and software which transforms some data into information. In simple language, it is written that computer is a combination of hardware and software which transforms input into the output. Means transforms some data. What is that data? That data is in the form of input, and after processing, means after transformation, it becomes information. So what is data and what is information? These both terms are important for us. We should know. So before that, just complete the discussion of definition of the computer. A computer is an electronic device that can perform a variety of operations according to a set of instructions called program. This computer can do anything. Whatever we can program systematically, means whatever we can plan logically. In last video we discussed this thing. But that must be instructed to the computer, and we can instruct with the help of programs. Programs are the language by which we can instruct to the computers. Okay. What is hardware, what is software, what is data, and what is information? All these four terms were used in the last slide. Hardware, the physical part of computer. Whatever the part we can see, we can use, we can touch, that is our hardware. And software, these are the instructions, these are the programs, these are the logical part which are there, which are working, but we cannot touch them directly. So basic difference is hardware we can see, we can use, we can touch. Software we can see, we can use, but we cannot touch. We can use, we are using, but we cannot touch. Now compare the hardware with yourself, software with yourself. Let's compare whole computer with yourself. Hardware, whatever the body parts we have, they are hardwares. They are hardware. And what is software? Whatever the thinking, whatever the thoughts we have, whatever the emotions we have, we cannot touch our emotions. We can feel our emotions, we cannot touch. So that is our software. Whatever we are speaking, we cannot touch our spoken words, but they are there. We can feel the effect of words. So the same thing is the software. Data, unprocessed raw data and fields. Means in a simple definition, in a simple language, data means meaningless facts and figures. Just see the examples: 22, April, Earth, etc. We have lots of data. Does it mean anything to you? Now, if someone of you will be having your birthday on the 22, so you will say yes, it is meaningful, but do not correlate directly with you. Just think 22, Earth, April. What does it mean to you? It does mean nothing. But when it is processed information, processed and meaningful data. Example, we celebrate World Earth Day on 22 April. Now it is an information. All the facts and figures that was provided as the form of data that is processed, and some other input is also there, but this is complete information. So this is meaningful for us, and that was not meaningful for us. If you do not know that World Earth Day is celebrated on 22 April, you cannot correlate. So that's why I am saying, do not correlate anything, whatever you know. You just read the definition and you try to understand the definition. The word which are used, try to get the meaning of that one. Because you know, but it is not required that everyone will be knowing that 22 April is World Earth Day. So, to understand data, pause your previous knowledge and just read the definition clearly. Means unprocessed raw data, and that is your input. That is data. Now, functioning of computer, how computer works, means now we know the definition of computer. Computer can do this, computer can do that, computer can do anything, computer can do everything. But how computer functions? Just like humans, as I told, compare computer with us, with human. So, as just like human beings, computer also takes input. Now you will be thinking, we do not take inputs, but we do take inputs. Suppose you wish to call your friend. So you wish to call your friend. This is the input for your mind. Now your mind will instruct to your hand to pick up the phone, to dial the numbers. That is processing. This instruction is given by our CPU, our brain. And now we are talking. This is the output. Suppose your friend told you to go and bring some pizza, cake, whatever, pastry, whatever you want. So that request or that is means the wish to eat pizza, pastry or cake or anything which you take, that is input. You are going market, processing, and you purchase that, processing. You bring that to the home, processing. These are all the steps of processing. And now you all are taking that, means you all are enjoying. This is your output. Means you purchased. Process of purchasing is the processing, but you purchased. This is your output. So in the same way, computers also function. Just like human beings, computer also take input. After processing the input, it gives output. All these steps are written here. You may read this. Okay. So that's why I was saying that compare computer with yourself, and it will give you a clear definition. It will give you a clear understanding. And one important thing also, you will not be focusing to memorize all the thing. You will clearly get the concepts. So do not pay attention or memorize the things. Just try to understand them, and they will be forever with you. Okay, we're coming to the next slide. Functional components. Functional components of the computers, these are the main parts, as we can say. They are important to define the functions of the computer. The computer mainly has 4 functions. The first, it accepts data, means it takes input. It processes data, means processing. It produces result, means produces output. This is output. And it stores the results for future use. If you will give instructions, then only. If you will not give the instructions, then computer will not store anything. But the computer has also this functionality. They can store as per the instructions given. And this is the storage. These are the 4 main functions: input, processing, output and storage. Let's see the next slide. This figure is given in the books, so please see this. Data flow. Input devices are used to give data to the computers, and processor is processing you with the help of main memory, and we can store also That's why storage is directly connected to the processor. If you are paying attention to this figure, you will see that input unit, output unit and storage unit all are directly connected to the processor. The arrow coming from the input device is unidirectional, means input devices are used to put information inside the processor. They do not get back anything. This is unidirectional, matlab means one directional arrow. And if you see the output unit, that is also connected to a unidirectional arrow, means output devices just receive the information from the CPU. They does not provide anything input, anything to back to the processor. But storage device connected with bidirectional arrows, means they give and take instruction to the computer. They receive instructions, they give data back. Main memory, that is also the part of storage, main memory, although that is a temporary storage, but that is also a storage. So that also have bidirectional, that give and take instructions back to the processors. So these four main functions of the computer: taking input, processing data, giving output and storage for future use. Okay, let's see next slide. Input function, how this function happens, and responsible for providing the information to the computer. Input function plays a vital role, because to process anything, the computers require some data. Computer requires input. That input is given with the help of input functions. In input function, we give instruction to the computer. The process is performed by input unit, means to give input we require one unit, and that unit is input unit. Okay. Input unit uses input devices. Means input unit is a combination of some input devices, and as per the requirements we use different input devices. So input devices we used to give instruction to the computer. Input devices are used to put information inside the computer. There are lots of devices, and we are not going to discuss all the devices here. So how we will categorize them, means without discussion or without reading anywhere else about that device, how we will come to know that is it input device or is it output device. So get clearly this information. The word input devices are used to put information inside the computer. If any device is used to put information inside the computer, that is input device. Now we will go to the next slide and we will come to know output. Output function responsible for displaying the processed data in human readable form. Means whatever the data, whatever the information is processed, output functions are responsible to display them in readable form, human readable form. Means we can read. That is not available in the machine language. That is readable, that is human, that is available in human readable form. And obviously this function is performed by output unit. Output unit contains lots of output devices, whatever the type of output we wish, and that type of device we have to use. Example of output device is monitor, printer, etc. And now the definition of output device. Output devices are used to put information outside the computer. Input devices are used to put information inside the computer, into the computer, and they are used to put information outside the computer. By knowing the functionality of particular device, you will be quite easy, means you will feel quite easy to categorize the devices without being familiar with the device. So please pay attention to the definition. It is going to help you too much. Now processing function, how it happens. To process anything, the CPU, the brain of the computer, is responsible, and there are some parts of the CPU that are responsible. Now let's see. The responsible means processing function responsible for carrying out the given instructions on given data. Whatever the instructions we have given, this unit is responsible to execute that, process that. Processing is performed by CPU. and CPU uses ALU. CPU means central processing unit. ALU stands for arithmetic logical unit. Somewhere it is written arithmetic logical unit, and somewhere it is written arithmetic logic unit only. So both are same. CU control unit. MU, somewhere it is written MU also, but you will not find MU. Everywhere it is written memory unit. So these three units are being used with the help of CPU. One main component is also there. We will come to them on the next slide. So CPU uses all these: ALU, arithmetic logic unit, CU control unit, memory unit to process the data. Now central processing unit, the components of CPU we will discuss. This figure is given in our books. Just have a look. Input devices directly connected to the control unit. Output devices directly connected to the control unit. Secondary memory directly connected to the control unit. Main memory directly connected to the control unit. And just arithmetic and logic unit connected with the control unit. Registers connected to the control unit and connected to the arithmetic and logic unit also. Memory unit, main memory unit is connected to the control unit and arithmetic and logical unit. Control unit, arithmetic logic unit and registers, these are the components of CPU. They are drawn in yellow area, means yellow rectangular area. It means they are the part of CPU. Okay. CPU consists of three basic sections, as we saw in the figure: ALU, arithmetic logical unit, arithmetic logic unit, control unit, registers. CPU is also known as very popular term microprocessor. Okay, microprocessor. Sometime we used to say a complete box, means a cabinet box near to the computer. We used to pronounce that CPU, but that is main system unit, MSU, and the processor, the microprocessor, the brain of the computer, that is the CPU. The whole cabinet is not the CPU, that is main system unit. Okay, so discuss ALU. We are going to discuss ALU, arithmetic logic unit. This is the combination of two units, arithmetic unit and logic unit. Means if arithmetical instructions are there, arithmetic unit is responsible to perform, and if logical instructions are there, then logic unit is responsible to perform. Logic unit is there. And what is arithmetic unit? I mean, what is arithmetical operations, what is logical operation? I think you will be knowing, but still we will discuss. The arithmetical operations means addition, subtraction, multiplication, division, that are your arithmetic operations. And for this, arithmetic unit is there. And if we have any logical operation, then logic unit is there to execute. Logic unit means to compare, concatenation, merger. These are not the arithmetical operations, these are the logical operations. Okay. Now registers, they are the very essential parts. They are also the type of storage. Registers are known as the temporary storage devices. Means they are not treated as the storage devices, but their purpose is to give temporary storage to the CPU. And why storage is required to the CPU, we will discuss. And registers are used during execution of programs, means execution of instructions, and they offer a very fast memory. Means execution is very fast, data transfer rate is very high, but memory size is limited. Registers do not offer huge amount of data storage. Now, why registers are required? The processing speed of CPU is very fast, but input dependent on the user, and users are not as fast as the registers. So registers are capable to execute, processors are capable to execute multiple instructions, means many instructions, but users are not capable to give that. So to give balance to the execution, registers are there. Now you will be thinking, if they are fast, if processor is capable of processing in a very fast, so what is the problem? If we are giving instructions slow, what is the problem? If we will give instructions very slowly, then we will be not, means then we cannot utilize complete power of computers. And one thing, when we start our computer, when we start our computer, sometimes we used to give lots of commands after, means just after starting, means when that screen appears, home screen appears, we used to click on the computer icon, we used to click on our files, we used to click on the media file, means as per our requirement. And sometimes what happens, doesn't happen, means computer is busy, we used to give lots of commands but computer does not respond, computer is waiting. And after some time we used to see a waiting icon, that wait, do not give more instructions. And just after some time, all the instructions execute. How? These instructions were stored on the registers because they offer a temporary storage to the CPU used during execution of program. Means when processor is busy to execute other instructions, that time processor cannot take new instructions. That's why registers are there to hold the instructions which are to be executed just after this instruction. Where the CPU will hold? CPU holds all these instructions inside the register so that CPU can directly execute the instructions. Okay, this is the use of registers. I think now the use of register is clear to you all. Okay, control unit. It does not perform any action directly. It works like the supervisor. Just like in our family, if there is any function, suppose in birthday party, engagement party, anything, then one person goes to each and every section but doesn't do anything directly. And suppose one person tells, okay, we have to organize this party, okay, Mr. A, you take the responsibility to invite the guests, Mr. B, you take the responsibility of food, Mr. C, you take the responsibility of location, means where we will organize this, venue, time, and one person is responsible for all other things, miscellaneous things. But this person which is in center, it does not hold any responsibility, but it goes to each and everywhere to see, are they performing their work on time, are they performing with coordination. Same thing, the same role is of control unit on our computer devices. If you memorize the figures which we saw, control unit was directly connected to the input devices, output devices, memory unit, arithmetic and logical unit. Every unit was connected with control unit to control them. Now see the definition. Gets the instruction from memory. Whatever the instructions are given, it receives the instruction from the memory and decides what the instruction means and directs the necessary data to be moved from memory to the ALU. Means whatever the type of instruction, if it is of type of arithmetic, it is a type of logical, both will go to the ALU, arithmetic and logic, and then ALU will decide where to execute. Now ALU performs the actual operation on the data. The result of the operation is stored in memory or register, depending on. Okay, control unit. What control unit does? Control unit received the information and decided to whom I should forward, and then instruction forwarded to the ALU, and now ALU executes, and after execution a result is stored in memory or registers. Now a word, instruction time. The first two operation of control unit is known as the instruction time. Means instruction time means whatever the time CPU took to receive the instructions, to understand the instruction, that is our instruction time. Control unit received the instructions and then he decided to whom means to which section we have to forward. These two steps are known as the instruction time. And last two steps, ALU performs the actual operation on the data and result storage. This is known as the execution time. This is execution time. ALU performs the actual operation of the data, result of the operation is stored in the memory. This is execution time, and this is instruction time. Both are important because in next slide we will discuss a term, machine time, machine cycle. Instruction time and execution time combines together to form machine cycle. A machine cycle is known as combination of instruction time, whatever the time CPU took to get the instruction, and whatever time CPU took to execute the execution, it in combined form known as a machine cycle. Okay. Characteristics of the computer means strength and weaknesses of the computer. They are known as the characteristics. So we will discuss strength first. Speed. Speed is very high, means execution speed, processing speed, high storage capacity. We can store a huge amount of data, ample amount of data we can store in computers. Accuracy. Computers are very accurate in performing the results, performing the execution. Means whatever the instructions we will provide, they will follow the instructions line by line. Means not a single dot will be added by the computers. Reliability. Computers are reliable, that they will give 100% result, 100% correct result every time, because computers are not biased. Just like humans, computers are not biased. So they will give accurate results, that's why they are reliable. And in another form they are also reliable, that whatever we have stored in the computer, that is not going to be deleted automatically. After some time, if we wish to use that data, we may use. Versatility. Computers are very versatile in the application. We may use for very easy tasks, we may use it for very complex systems, means however we wish we can use. Because of this versatility, computers are popular in each and every sector. Nowadays, in each and every sector, in each and every section, computers are being used. Okay, this is just because of the versatility. Weaknesses of the computer. Zero IQ. Computer cannot think of itself. From the first slide I am discussing this. Computer cannot think of itself. Computer cannot perform any action by their own. Each and everything they will do based on our instructions. Okay. Lack of decision making power. Computer cannot decide anything. This computer cannot decide by their own. Whatever the instruction we will give, they will execute only. And whatever the result, that is the result of your instruction. That is not their decision. Just like our judges used to give decision in the courts after listening to parties. Computer cannot decide. No heuristics, means learning from past experience. Suppose as a human being, we used to perform something, and if that creates a bad result, we get a lesson, and next time we do not repeat these things. But if you perform same error every time, computer is not going to say you anything. Computer is not going to warn you. The same process you are doing, this mistake you committed yesterday, no, computer is not going to say. So no heuristics. Computer does not learn anything. Everything you do, that is new for computers. They do not know anything. They do not have history. They do not store your history. Means whatever the execution, whatever the instructions you given in the last, given in past, you should not repeat in future. No. So these are the weaknesses of computer. Now types of computers. This is also very important. So computers are categorized on the basis of their application, means their purpose, and on the basis of their technology. So we will discuss all. First, purpose by categorization, special purpose computers and general purpose computers. The special purpose computers were designed to perform some specific task like scientific work, like for doctors, for research laboratory. They are very complex. So these are not versatile devices. Means the computers which are designed for a special purpose, they are not versatile because they are designed to perform some specific task. And general purpose computers, they are known as versatile computers because they are general purpose. We can use for each and every sector, however the possible by the capability of that computer. So general purpose means they are not designed to perform a special task. They are designed to perform all the tasks that is possible. Okay. Categorization of computers on the basis of principle or operations. So this is there are three main categories: analog computers, digital computers, and hybrid computers. Analog computer work with continuous data, means that receives signals like doctor. We used to go to the doctor, so please check our blood pressure. They apply a device, the mercury goes high, up and down, and after some time they used to tell, yes, your blood pressure is this. That is analog. We have voltmeter in our houses that tells current voltage is 220 volt or 200 volt. We have odometer in our motorcycles, motor vehicles, four wheelers that tells us the speed with the help of one needle moving from 0 to the particular speed. As we accelerate the throttle, we get the movement of that needle through the screen. These are analog systems, analog devices, analog computers. Now why we are saying these are the computers? Because now memorize the definition. One who computes is known as the computer. Calculator is also termed as the computer because that calculates. So now they are analog computers. Okay, we go to the doctor for our ECG. Still there is one analog device, analog computer that receives the signal. So they are the continuous data. Analog signals are continuous data, and the computer which is capable to understand or process this continuous data, that is known as the analog computer. Digital computer, it works with discontinuous data, means they cannot process that continuous data, continuous input. They work on converted. Discontinuous data means converted data, and computer understands binary, so convert it into binary. Nowadays we may see doctors having a digital blood pressure checking machine. They apply and they tell, yes, this is your blood pressure. Now ECG machine is also digital. In some models of vehicles, odometer is also digital, voltmeter is digital. Everything is going on digital because on analog computers we need expertise to get the output. But on digital computers we do not require any expertise because everything is written in the form of digits. But analog computers gives accurate results. Digital computer may not provide accurate result every time because that continuous data is converted into digits, and at the time of conversion that input may change. But digital computer will provide you the result on the basis of result captured. So it may not provide you correct result every time, but analog computers provide 100% result every time. But it depends on the user. Is he capable of reading whatever the data analog computer is providing? The hybrid computer, it utilizes the best qualities of both, means it uses the best property of analog computer also and best property of digital computer also. Okay, types of digital computer. Digital computer can also be specified, or digital computer can also be special purpose or general purpose computer. Means we discussed purpose wise special computer, special purpose and general purpose. So digital computer can also be a special purpose computer or digital purpose computer. Based on the size, based on the capability of that computer, means based on the size, based on the speed, the digital computers are categorized further. Now see that categorization also. Embedded computer means the smallest computers. They are in the form of tiny chips embedded within the circuitry of appliances, and they are programmed for a specific task. just like the toaster. They have different timers. Microwave ovens, they have different timers. Means if you wish to set the time for 5 minutes, after 5 minutes the machine will off automatically. How it is happening? Because of that embedded computers. In our washing machines we have the timer for 30 minutes, 15 minutes, half an hour. How it happening? We have an embedded computer there, and they have the instructions. Whatever the instructions we tune for 30 minutes. So after 30 minutes that computer automatically closes the operation of machine to help us. So this is embedded computer. They are very small. They are in the form of tiny chips. Microcomputers, they are also known as the personal computers. Normally use a single microprocessor. They comes with a single microprocessor. Normally they may have more than one processor, but normally they come with a single microprocessor, and they are designed to perform a single user application. Means they are designed for single user and suitable for education, training, small business, etc. Because it is also a general purpose computer. Now microcomputers can also be categorized in further categories like mobile or handheld computers, portable personal desktops, desktop PCs or workstations. Let's see, mobile or handheld devices. These devices which we can carry in our palm, that is known as the mobile or handheld devices. That device must be coverable in our hands, holdable. That is known as the mobile or handheld devices. Handheld computers. The best example is smartphone, tablets. Okay. Portable PCs which can move easily. Means from one place to another place we can carry easily and we can use. Means we need not to configure every time. Laptop, notebook, PDA, personal digital assistants. They are the devices like of digital diary type. So these are the portable PCs. Means we can carry them easily. Desktop PCs, that is known as the personal computers. They are not movable, but they are also small in size. So they are in the category of microcomputers. Workstations, they are similar to the personal computers, but they are more powerful. Means in terms of memory, they have larger memory, and they uses more processors to execute faster. They have more power than the microcomputers, than the personal computers, and also connected to the other workstations or personal computers to exchange data. If desired, they have the possibility to be connected. Okay, these workstations are mostly used for scientific or industrial or business environment. It is not the general purpose device. So now next, mini computer. This mini computer is the categorization of digital computer. It is not the categorization of microcomputer. Portion of microcomputer was in our green color heading. Okay, so do not get confused. Mini computers is the categorization of digital computer. The first was embedded microcomputers, now mini computers. They are also known as the mid-range servers. Means they have the capability to perform like server also. They are as powerful. They are more powerful than microcomputers. Okay, mainly supports multi-user system. In our microcomputer it was mainly single user system, but they mainly support multi-user system. Multiple users can work simultaneously. Example of popular mini computer was PDP-11, VX, 7500 Magnum, etc. Now mainframe computers, the next category, mainframe computers. They are designed to handle huge volume of data and information. Means they are more powerful than mini computers also. They can support more than 100 users, and they are multi-user and multi-processor system. Means they can use more than one CPU. They are designed to use more than one CPU, and they also support more than 100 users at a time. And they are, means for mainframe computers we require very sophisticated operating system, means very complex operating system that can control and supervise the mainframe computers, because they are not the general purpose devices. They are also, means they may be used, but they are more complex. So they are, we cannot say they are general purpose computers. Example of popular mainframe computers have ICL39, CDC 6600, VAX 8842, IBM 3090/60. supercomputers, the most powerful computers, and they are very fast because of several processors. They can handle huge amount of calculations, and they can perform billions of instructions per second. Means they are more powerful than many computers, microcomputers, mainframe computers. They are supercomputers. Some supercomputers are capable of computing 40,000 microcomputers. Means 40,000 microcomputers, the processing capability, the computing capability of 40,000 microcomputers is equals to single supercomputer. You can easily see the difference, easily see the power, mainly used in applications like weather forecasting, nuclear science research, etc. Means these supercomputers are used for very huge data calculation like forecasting. The popular supercomputers which were designed: Cray XMP14, CDC205, ETA GF10, Fujitsu VP400, NEC SX2, Param, Pace, etc. So see the figure of this types of computer, it is also given in your book. Okay, so thanks. The chapter 1 is complete. We will discuss next chapter in our next video.